the next lesson that we'll be reviewing is we are basically combining the factoring and multiplying binomials and the graphing parabolas in this upcoming unit. So let's make sure that you all remember how to factor. So, warm up. Let's factor the following expressions. I'm also attaching the condensed factoring flowchart, as you can see, as reference. So, factoring flowchart. What would we do? So, first thing, for the first one. First thing you always find, is there a common GCF that all your terms share? If there is, please do this first. Is there a common GCF that 6x squared and negative 9x share? I'll give you a moment to think about it. Hopefully you all got the same answer. They all have 3x in common. So let me do some rough work on the side to make sure you know what I'm talking about. So we have 6x squared divided by 3x. And that gives us 6 divided by 3 gives me 2. X squared divided by x. Using my law of exponents, since x squared is simply just like saying x times x, and then divided by x, I basically am canceling out one of my x's, and I still have one x remaining. And then for the other one, I have negative 9x divided by 3x. Negative 9 divided by 3 gives me negative 3. And we have an x divided by an x. All of those x's cancel, so I'm left with no x's whatsoever. So I'm just left with that negative 3 after I divide out the 3x. Amazing. Okay, let's see if we can factor further. How many terms do I see? I see 1, 2. Since terms are separated with the plus or minus. So I have 2 terms in my brackets. Okay, is this a difference of squares? Let's find out. Difference of squares is if we can we square root the first term? Can we do the square root of 2x? Can't do this 2. We can't do the square root of 2, and we can't do the square root of x. So no. The first condition does not apply. So that's all we could do. Let's change it to color. So now it's not a difference of squares. Okay, next thing. Okay, with the next one, is there a common GCF that all of our terms share? For the next one, sorry. First thing we do, is there a common GCF that all of our terms share? Is there a common GCF that x squared, 5x, and 6x all share? I'll give you a moment to think. No, there is no common GCF. So, next thing we're going to do, how many terms are there? 1, 2, 3. Okay, so 3 terms. So, that means it could be a perfect square trinomial, could be a simple trinomial, could be a complex trinomial. What do you remember about it? Let's first determine, is this a perfect square trinomial? Can we square root our first term? Square root of x squared, x, okay. So far, so good. Can we square root our last term? Square root of 6. Oh, we can't do that. So it's definitely not a perfect square trinomial. I don't even need to check the other conditions. Okay, next thing. If the number in front is, if the coefficient in front of our square term is 1, then it is a simple trinomial. Okay, simple trinomial. So I know when we factor simple trinomials, we find the product and we find the sum. The product is always found from a simple trinomial, is always the constant term. So in this case, it's 6. And my sum is simply the number of my middle term. So in this case, it's 5. So now I'm looking for two numbers that when multiplied give me 6, but when added give me 5. My suggestion is start with the factors of your product. So numbers that multiply make 6, I know are 1 and 6, 2 and 3. Are there any more? No, we got them all. So let's figure out which of those numbers can, when added, give me 5. 1 plus 6. Oh, that gives me 7, so that's not an option. What about 2 plus 3? Oh, 2 plus 3 gives me 5. Oh my gosh, I found my numbers. My numbers are 2 and 3. And since it's a simple trinomial, we have our brackets. I guess I should want to go back to my other one. Okay, have my brackets. What letter am I working with? I am working with x. X goes in one bracket, x goes in the second bracket. What were my two numbers? My two numbers was, first number was plus 2, second number was plus 3. And guess what? We're done. Okay, for the next one. So first things first, is there a common GCF that all terms share? Let's find out. Is there a common GCF out of x squared and negative 16? Let's think. No, there's not. And how many terms do we see? We see 2 terms. So is this a difference of squares? Let's find out. Can we square root the first term? Can we square root x squared? Yes. X times x gives me x squared. Awesome. Next one, can we square root our last term? I completely know that there is a negative sign in front of my second term. Please ignore it for different squares. Please just ignore it. So can we do the square root of 16? Yes. 4. 4 times 4 gives me 16. And last condition, is there a minus sign in between? Yes, there is. So it's a difference of squares. So for difference of squares, when we are factoring it, bracket, bracket, the number we have is, the square root of our first term is x. So x goes in one bracket, x goes in the second bracket. And then the square root of our second term was 4. So 4 goes in one bracket, 4 goes in the second one. And for a difference of squares, one bracket will have a plus, one bracket will have a minus. And guess what? We're done. Okay. So then we have simple trinomial factoring. This is just to get used to all the different types of factoring. So product, sum. My product will always be my constant one, the one with no variables. And my sum will always be the number of my single variable term. So not my squared term, but my single variable term. And I'm going to try to find two numbers that multiply to make negative 32, but add to make negative 4. One way you can do that is find the numbers that multiply to make my product. So I know that's 8 and 4. And because my product is negative, I know that that means that one of my numbers will be negative and the other one will be positive. And I think, let's just verify, I made negative 8 plus 4. That does give me negative 4, which is what I wanted. And just to verify, negative 8 times 4 gives me negative 32, which is my product. So I think I just found my numbers. Negative 8 and positive 4. So then for factored form, bracket, 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 bracket. The variable that I have, the letter that I'm working with is D. D goes in one bracket, D goes in the other one. Then I have D negative 8 and D plus 4. Next one, product, sum. My product is negative 8. My sum is negative 7. Again, two numbers that when multiplied give me negative 8, but when added give me negative 7. Let's see what those could be. So I have 1 and 8, which, again, the product is negative, which means that one of my numbers will be negative and the other will be positive. And I think I also just found my numbers too. Let me just verify. Negative 8 plus 1 gives me negative 7. And negative 8 times 1 gives me negative 8. Okay, so I think we're good. I think we found our numbers. The letter I have is U. U goes in one bracket, U goes in the other. Minus 8 plus 1. Done. And next one, product, sum. Product is 28. Sum is 11. Two numbers. 7 times 4 gives me 28. But my product is positive, which means that both of my numbers are positive or both of my numbers are negative. And because my sum is positive, that means that I'm looking for two positive numbers. So I'm still looking. 1 and 28, no, I doubt it. That gives me 29, which I don't want. This gives me oh wait, actually let's go 11. Oh, my mistake. Yes, my numbers are 7 and 4. N, since we are working with N goes in one bracket plus 7, and N plus 4 goes in the second bracket. Okay, so this is a simple trinomial factoring. So remember, if it has 3 terms and the number in front of your squared term is equal to positive 1, then it's a simple trinomial. And the simple trinomial factoring, as you can see, so simple, amazingly simple, but only if this is a simple trinomial factoring. You need to be able to identify what kind of factoring you have to do. Let's practice some complex trinomial factoring. So I know that the number in front of my squared term, if it's not equal to 1, then it's a complex trinomial. So my product and my sum, just like with the simple trinomial, my sum is always the number in front, the number of my single variable term. In this case, it's 17. My product I have to find by doing 6 times 5, because for a complex one, I multiply the number of my squared term, the coefficient, and my constant term multiplied together gives me 30. So I'm trying to find two numbers that multiply to make 30, but add to make 17. My suggestion is always find the numbers that multiply to make your product, because that limits the possibilities. We have 5 and 6, but those don't add up to 17. I know that gives me 11. I have 15 and 2. Oh, wait. $15 plus 2 gives me 17. Oh, I found my numbers. Okay. But just because we found our numbers doesn't mean that we're done. With a simple trinomial, once we found our numbers, we did the last line, we were done. But for the complex one, unfortunately, that's not the case. I have to do a little bit more work. So I'm going to rewrite everything, the first term and the last term, and my middle term splits. So I'm literally taking the numbers that I just found and using those numbers to split my middle term. Then from there, I would do some factor by grouping. So I put brackets around my first two terms. And brackets around my next two terms. Find the GCF. GCF between 16 and 15t is 3t. I'm left with 2t plus 5. And here they have nothing in common except for 1. Now, what does my new first term have in common with my second new term? They both have the 2t plus 5. Then what I'm left with is the 3t, and I'm going to highlight where I'm getting that from, so we're all on the same page. And that's it. That's complex trinomial factoring. Let's do it again. Product, sum. My product is 10 times negative 5, which is negative 50. My sum is negative 23. My two numbers, since my product is negative, I'm looking for two numbers that when multiplied give me negative 50, but when added give me negative 23. I think those are negative 25 and 2, but I just want to verify that it satisfies all conditions. Negative 50, yup, I'm good on that. Negative 25 plus 2, negative 23. So yes, I found my two numbers. Negative 25 and 2. P squared, splitting my middle term to be negative 23p plus 2p. Sorry. 10p squared minus 25p plus 2p minus 5, grouping 10p minus 25p, 2p minus 5. GCF that my first term shares is 5p, 2p minus 5, and that's my GCF for my second bracket is literally just 1, so I'm just bringing that out. What am I left with? 2p minus 5, 5p plus 1. Amazing. And I'm gonna do this again. 6p squared. Love that I did this question. What's the first thing we always do when we factor grade 10s? Is there a common GCF that all of my terms share? Do this first. I know these are all even numbers like 2, 4, 6, 8, continuing on. So let's see if I can factor out. I can only factor out 2. So I'm going to divide 2 out of everything I see here. 56. 56. I want to verify that. I want to just verify. Yeah, 28. Okay. Just want to verify. Okay. Now I have my product and sum. My product is 3 times negative 20, which gives me negative 60, and my sum is negative 28. 2 numbers, which I believe, I think are negative 30 and 2, but I'm saying I think, so I just want to verify that. Negative 30 times 2 gives me negative 60, and negative 30 plus 2 gives me negative 28. So yes, I did find my numbers. I'm going to do a little shortcut. So let's see. I'm going to pull out all the GCFs in my first bracket. So the GCF between my first 2 terms is 3p. And that would leave me with p minus 10. Now I'm going to go to my second terms. My GCF that's there will be plus 2, and I want to verify that if I did 2p divided by 2, it gives me p, and it does, and then negative 20 divided by 2 gives me negative 10. Yep, I'm good. And I'm done. Okay, so then we have some common factoring. So it's the GCF between 8 and 6x to the power of, 8 plus 6x to the power of 4. Next one. And then actuality here, we can continue factoring because this is a simple trinomial. And the last one, GCF. And that's, oops, sorry, this one's. Okay. And we have difference of square factoring. We have to see if we can square root the first term, square root the second term, ignoring the minus sign.
2w plus 9 in one bracket and 2w minus 9 in the second bracket, and done. And the next one, it's also difference of squares. And the last one. Yeah. Okay. So the perfect square trinomial. Perfect square trinomial, we have to see if we can square root the first term, square root the last term, and if the middle term can be achieved by 2ab or negative 2ab. The sign in this at this moment in time does not matter. I can square root q squared to make q. I can square root 4 to make 2. So 2 times q times, my square root of 4 was 2. So I want to hope that I get negative 4q, and let's just check if I do. Q times q, 2q times 2 again, 4q, and if I just put a sign in front of it, yeah, this is perfect square trinomial. So once I prove it's a perfect square trinomial, q, because the middle term has a minus sign, q minus 2 squared. I'm gonna just, spoiler alert, these are all perfect square trinomials, so let's continue. And then that. And then I want you to try the homework. I'm not gonna give you the answers, but when I post this notes to the classroom, I will probably just post with the answers.